Good morning, everybody. I sure hope that you're having a really good day, and if you're not, then I sure hope that turns around for you really soon. I hope that you all understood yesterday, and if you found that you ran out of time to show the whole thing, those of you that are tech savvy, this lesson will probably be a little bit shorter. So if you have time, you can go ahead and replay yesterday's, figure out where you were, and go back a little bit, and make sure that you are done assignments 50 and 51 for Monday morning. Make sure you have any questions that you may have. Alright, so this is a very, very important lesson. It's a theorem that you've probably encountered some point in your life. And it's called the Pythagorean Theorem. And even if you don't know what it's all about, you probably have at least heard the term somewhere in your travels. It is very, very useful, especially if someone were doing any kind of surveying project or building. People have used this for a very long time. It was developed by Pythagoras, and his name got attached to it. So the Pythagorean theorem has a lot of complicated words for something that's fairly simple. So we're going to start with the wordy part of it, and then I'm going to explain a little bit of extra credit you can do, and then we're going to make it super, super simple. Okay, so Theorem 9.4, the Pythagorean theorem. In a triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the sides. We could change that to saying the other two sides, or to the legs. As a matter of fact, I think I like that just a little bit better. And I'll just put in parentheses here, legs, and we'll make it a little bit clearer. Okay? Okay. So, the legs of the triangle. So let's take some time to write that down, just like I did yesterday. I'm going to do this in real time, so I'll write while you're writing so that you have enough time. So this is Theorem 9.4, the Pythagorean theorem. States that in a triangle, the square of the length of the hypotenuse is equal to the sum of the squares, or the sum of the squares of the lengths of the legs. Okay, so we are going to take that and make it very, 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 very simple very, very soon. Like I said, it sounds really complicated, but really it is very simple when you really start to break it down. It's just hard to put it into words. As a matter of fact, very famous movie that you all know, The Wizard of Oz, they attempted to say the Pythagorean theorem when the scarecrow got his brain. Unfortunately, they botched it horribly. And if you play it a few times and you slow it down, so that you can actually tell what he's saying, and you write down what he said, he makes a horrible mistake, and it isn't true what he ends up saying. Okay, so I think it's worthwhile if you take the time to look up that clip where in the Wizard of Oz where the scarecrow gets his brain, and write the quote that he says, write it out exactly the way you hear it. And you can explain by an example why it's false. Use your best words along with the example. then I will give you 5 points of extra credit on your test. But it's got to be a good explanation, has to be a good example, a good counterexample as far as why the scarecrow really didn't show his intelligence when he said that statement. But you know, that's something fun that you can do and maybe get yourself some extra credit points. It is due right at on the test day. I'll let you have that right along with your notes sheet. You can staple it to your test and hopefully get those bonus points. Alright, and that's all on you. Not going to be reminding you of that. So let's get back to this Pythagorean theorem, the real Pythagorean theorem, and what it really means. It says, in a triangle, it should say in a right triangle. It only works in a right triangle. So we should actually add that. I don't know if I typed it wrong or if I wasn't paying attention, but I know it's in a right triangle. The square of the length of the hypotenuse is equal to the square of the lengths of the other sides. So we can draw a triangle like that. The legs we call A and B. Well, I made a mistake. It should say right triangle. So let's just add that in a right triangle. And I'll put that in red so that you remember to just add that in. In a right triangle. The square of the lengths. Oh, that's special. Okay, in a right triangle, the square of the length of the hypotenuse, which is the longest side, is equal to the sum of the squares of the lengths of the legs. Okay, so we want to make sure that you have got that you have it accurately written, and we'll take a look at this picture. Bring this legs up. Oops. So here A and B are the legs, and C is the hypotenuse. That's old news. But what this is saying, the square of the length of the hypotenuse, that's C squared, is equal to the sum, add A squared and B squared. In other words, A squared plus B squared equals C squared. It's a pretty simple thing. As a matter of fact, when I get back, there's a fun little song, YouTube video that you can take a look at that will make it so that it's impossible for you to forget. It is very catchy, and you will remember that A squared plus B squared equals C squared without any problem. Okay, so in a right triangle, A squared plus B squared equals C squared. Very, very, very important theorem. Now, I am going to take a couple minutes to show you a proof. It's actually more of a paragraph proof to show you why that this is true, but the way that we're going to really emphasize it is how to use it, okay? But it is useful for you to see why the Pythagorean theorem is actually true. So, paragraph proof of the Pythagorean theorem. Okay, first of all, here's A, one leg, B, another leg, and C, the hypotenuse of this big right triangle. So we have the information about geometric means so that we can write proportions. So we're going to write two proportions from this. We know that A is a geometric mean of C and E, and we know that in this picture B is a geometric mean of F and C. So we can get this proportion. Here are the geometric means, and here are those other pieces that we spent a long time talking about yesterday. Now, what we can do with that is we can cross multiply, which you're very used to doing. So EC equals A squared, and B squared equals FC. Then if you add A squared and B squared, that's the same as adding EC and FC. Okay. Now I would rather you really pay attention and follow right now than be writing. I'll give you enough time to write it down, but just to recap, we've got this picture here. Look up if you're writing. I'll give you enough time to write it down. We have this picture here, A, B, C, and we're trying to show why A squared plus B squared equals C squared. So, set up the proportions. These are the geometric means. Cross multiply. Then understand that when you add A squared plus B squared, that's the same as adding EC plus FC. Alright, some of you are probably starting to see where this is going. If you add these together and then you factor out a C, because a C is the common factor. So you factor out the C, we have C times E plus F. And C's in common here. Here's where some of your factoring that you were doing in Algebra 2, those Algebra 2 students, comes in a little handy. But how much is E plus F? E plus F actually equals C. So we can replace this E plus F with a C. So A squared plus B squared equals C times C, which is C squared. So a very nice little bit of algebra that comes down through and shows why A squared plus B squared equals C squared. I would like you to jot that down in your notes. Even though, I'm not going to ask you to prove the Pythagorean theorem, it is really good for you to get a good sense of why something is true. It's not a formal proof, as you can see. However, if you can understand the different steps, you can tell, these things are not just made up. They actually come from real math that's backed up by other real math. So we're going to draw the picture. This is where you take the time to draw it. Label all your different parts. We have an A and a B, and C is the hypotenuse. But then we have the little parts, E and F, and then D down through the middle. We use the geometric means. To write proportions. Okay, so E over A equals A over C, and F over B equals B over C. Then you cross multiply. So that EC equals A squared and FC equals B squared. So that when you add A squared and B squared, you get EC plus FC. Then you factor. A squared plus B squared equals E plus F times C. And then you replace E plus F with C. A squared plus B squared equals C times C. And then finally, A squared plus B squared equals C squared, and you're done, and you've shown why it works. So now that we know why it works, we have to get some practical examples as far as some problems that you would be asked to solve using the Pythagorean theorem. Alright, so let's get one of these. Write down this problem. If you have a right triangle, we want to solve for x. Alright, so this example, we have a right triangle, 4 and x are the legs, and 10 is the hypotenuse. Find x. So we know that in just such a scenario, it's leg squared plus leg squared equals hypotenuse squared. So we have leg squared plus leg squared equals hypotenuse squared. So what you need to do then is you need to solve it. We square 4, we square 10, and we get x squared plus 16 equals 100. Let's make sure we write that down. So you have x squared plus 4 squared, leg squared plus leg squared equals hypotenuse squared, 10 squared. So that means that x squared plus 16 equals 100. You should all know then that you subtract 16 from both sides, so x squared ends up equaling 84. Okay, x squared equals 84. Then since you've got a square, you need to use square root in order to simplify it. Now since we have square root, what we could do is we could let the calculator do the work, and depending on the place value you're asked to round to, if it's the tenths place, you'd have 9.2, about equal to 9.2, about equal to 9.17 if you're asked to round to the hundredths place. If you're asked for radical form, or to give the answer as a radical, remember you can take 84 and factor it, so that's 4 times 21, which is a 2 and a 2. So that means that underneath you have 2 2's and a 3 and a 7. 3 and 7 don't have a partner. Okay, so 3 and 7 stay under, and 1 2 comes out, so you get 2 times the square root of 21 equals 9.2, or 9.17. Let's make sure everybody has gotten that written down. 4, 2 times 2 times 3 times 7. So x is 2 times the square root of 21, or about equal to 9.2 or 9.17, depending upon whatever the directions say. Always read the directions and do what they say, and if you're in doubt because it doesn't tell you which is specifically the answer for that, always raise your hand and ask the question. Alright, so that's that one. I do have a special note here that you should jot down. You might be asked to give your answer in radical form, like I said, but you may be asked to give it as a rounded decimal. You need to be able to do both. You need to be able to recognize both. In some contexts, in some type of situations, the decimal is much more useful, but in some scenarios the radical form is much more useful. So jot that note down. Okay, you may be asked to give your answer in radical form, but you may be asked to give it as a rounded decimal. Okay, so do not forget your rules of rounding. They become important all the way through. Alright, I believe we're ready for another example. Here's another one. This one also has a right angle here in the corner. This only works for right triangles. Only works for right triangles. You're being asked to solve for x here. So let's make sure you've got this example written down into your notes. Show the picture so that you know what you're looking at. 3, 4, and x, and you're supposed to find x. Alrighty. When you get ready to set it up, once again, a squared plus b squared equals c squared. This time the c is over here by itself. A squared, 3 squared plus 4 squared equals x squared. And we're going to find something very interesting happens with this particular example. 3 squared is 9, 4 squared is 16, as you know. When you add those, you get 25, and when you square root both sides, you get 5. Okay, so let's let that sink in just a little bit. Okay, you set it up as 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. When you add 9 and 16, you get 25. So x equals 5. It is very convenient that it came out even, so you didn't have to worry about radical form or rounded decimal. Now, when all three numbers for the sides of a right triangle come out to be whole numbers, there's a special name for that. And that special name is a Pythagorean triple. If all three sides of a right triangle come out to be whole numbers, that set of numbers is called a Pythagorean triple. Okay, so 3, 4, 5 is a Pythagorean triple. And some of you might think, well, gee, does that work for every set of three numbers that are right in a row? And no, it doesn't. So you're going to discover some Pythagorean triples as you go through and do your homework. So just keep on the lookout for them. Okay, Pythagorean triples are important when you take SATs, and we're going to look more at Pythagorean triples as we go. It is good to know what some of the common Pythagorean triples are. So you're going to make sure that you begin to be very, very aware of them. It saves you time, because if you know 3, 4, 5 is a Pythagorean triple, then you know that 3 and 4 are the legs. You don't even have to go through the whole process of a squared plus b squared equals c squared. You just know it's 5 because you're very, very familiar with that Pythagorean triple. So and that saves you time. You need to make sure that you are very, very careful with your time on the SATs. So let's write this down. If all three sides of a right triangle are whole numbers, then that set of numbers is called a Pythagorean triple. So 3, 4, 5 is a Pythagorean triple. Alright, that should be enough time for you to have written it. Alright, let's move on. Here's another example. Still a right triangle. We need to find x. So let's get this example jotted down. Okay, we have 5, we have 13, we have x. We're supposed to find x. Okay, so now you need to make the decision as far as where the x belongs. This x is a leg, and the 5 is a leg, and the 13 is your c. A squared plus b squared equals c squared. So we'll set it up. X squared plus 5 squared equals 13 squared. Okay, make sure you process that in your mind. X squared plus 5 squared equals 13 squared. 13 is the hypotenuse, that's why it stands all by itself. And these two legs, here's a way sometimes people have trouble determining which the legs are. The legs always make an L shape. Okay, the legs are the ones that are on the right angle, so leg L. That might help you figure out and be always confident that the legs are making an L there, and you can use those as A and B. Okay, so we do this little bit of math. X squared plus 25 is 169. And then subtract 25 from both sides. Now when you square root this, we get another whole number. Okay, so x squared plus 25 is 169. X squared is 144, so x equals 12. So what does that mean? That means that 5, 12, 13 has a special name, and it is a Pythagorean triple. So that's another triple that you should try to make yourself know off the top of your head. It can save you precious moments on the SATs, and they do like to throw in those Pythagorean triples because it speeds up your math. It allows them to check for other concepts, but it doesn't speed up your math if you don't recognize and commit them to a little part of your brain. Okay, there's nothing horrible about memorizing certain things. So 3, 4, 5 is a good Pythagorean triple. 5, 12, 13 is also a Pythagorean triple, and we'll look at a lot more Pythagorean triples as we go. Alright, let's move along. Word problems. Word problems can be solved using the Pythagorean theorem. So let's take a look at here. You have a 6-foot ladder, but that doesn't mean that you can always climb to 6 feet high. Okay, that 6-foot ladder may not reach as far on the wall as 6 feet. The 6-foot ladder is leaning against a wall. If the foot of the ladder is 1 foot from the wall, how high does the ladder reach? Okay, now that's actually a reasonable question. You would want to know how high up you can get with that ladder. Another reasonable question would be possibly one where you know how high you have to get and how far away from the wall you'd put the ladder, and you want to find how long of a ladder you need. So there are some very practical questions, but let's take a look at this and see how this relates to our Pythagorean theorem. Okay, so let's take a moment just to jot down the question before we get too far ahead of ourselves here. So a 6-foot ladder is leaning up against a wall. If the ladder is, if the foot of the ladder, or the base of the ladder, or the bottom of the ladder if you don't understand foot, so if the bottom of the ladder is 1 foot from the wall, how high does the ladder reach? Okay, so it does help, definitely helps to sketch out a picture. So here's a picture. We have a wall. We have our ladder. The ladder's 6 feet long, and it's 1 foot. The bottom is 1 foot away from the bottom of the wall. So we do have a nice little right triangle going here. So I want you to take a moment and I want you to sketch out that little picture. Your picture may be better than mine, and that's fine. Okay, but it just has to be a rough picture so that you can get an idea of what's going on. So you've got a ladder, and it's a 6-foot ladder, and it's 1 foot from the bottom. Okay, so our next step is actually to make it into a right triangle. You can see the right triangle coming out here, but if you pull that right triangle aside, Okay, here's that right triangle. You pull that right triangle out. You bring your 6 over, you bring your 1 over. Then it is a picture that looks like something pretty simple to solve with the Pythagorean theorem. Okay, so let's jot that picture down, that revised picture. It does have a right angle in it. Where the wall meets the ground is hopefully a right angle. And then Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. So that looks like this. 1 squared plus x squared equals 6 squared. And get that written down. 1 squared plus x squared equals 6 squared. Then begin to do the math. Okay, so we have 1 plus x squared. 1 plus x squared equals 36. Subtract 1 from both sides, you get 35. 35, the factors are just 7 and 5, so you can either leave it as square root of 35, or if you put it in your calculator, you'll get about equal to 5.92 feet. You might say, well, that's pretty close to 6 feet anyway, Sister Doughty, but it's not quite 6 feet. So if you had something that you needed to get to that was 6 feet high, it wouldn't work. It wouldn't be long enough. So 5.92 feet, and if you wanted to be a little safer and pull this out a little bit further and put it at 2 feet, your ladder would reach even not even quite as high as that. So that's just a practical problem. Let's get that written down. So x squared is 35. So x is the square root of 35, or 5.92 feet. Okay. Now I had told you that this lesson was much shorter than yesterday's. I believe that that was accurate. So if you have time and you're tech savvy enough to go back, you can go back. Assignment number 51 is due on Monday, along with assignment 50. If you haven't put it in there and you have questions, you can go ahead and ask me on Monday any questions that you may have. And have a really, really blessed weekend, and I will see you on Monday.